Are you ready? Okay, we're ready.
In 1962, a treaty was signed by the French and British governments. They would pool resources and knowledge and work together to build the world's first supersonic commercial airliner. Both countries had already independently begun working on designs, one from the Bristol Aeroplane Company and one from Sud Aviation, and both had reached a stage where they were ready to build a prototype by the early 1960s. The Second World War had stimulated huge progression in aviation, resulting in the post-war jet age and the birth of supersonic flight. Money was pouring into commercial aviation in the 1950s, yet despite this industry boom, the cost of designing a supersonic airliner was more than the BAC or Sud Aviation, now called Aerospatiale, could manage. Thus, the treaty between France and Britain was signed, and the Concorde project was born. It was now up to the engineers and experts to turn this ambitious concept into a reality. So how did these teams possibly reach this stage? Other similar projects worldwide from the United States and the Soviet Union had both ended either in the production stages or soon after launch. Indeed, the construction of Concorde was one of the most complex operations ever undertaken in the aircraft industry, and it was developed across 2 countries in 2 languages. And yet, despite these huge complexities, by 1969, 2 prototypes were ready to take their first flights. Concorde 001 completed her maiden flight from Toulouse in 1969.
The world's first sight of a supersonic airliner. Sleek, purposeful, imposing. A supersonic airliner that will give Britain and France an assured and profitable place in the vast civil aviation market of the 70s. The debut of Concorde.
But the prototype aircraft were far from ready to be opened up for supersonic passenger flights. It would be another 8 years until Concorde would take her first commercial passenger flight in 1976. And that's where Concorde 101 and 102 came in. These pre-production aircraft were the 3rd and 4th Concordes built. Their purpose was for the testing and refinement of all of Concorde's problems, from how to deal with ice build-up on the wings to seeing how Concorde would cope travelling at Mach 2 in thin desert heat. The testing of Concorde would go on for 7 years. So how was Concorde 101 equipped to test supersonic flight to the extremes? And what did she accomplish?
So this particular Concorde is the fastest by far, by 100 miles an hour. It found when you went that fast, it got too hot and the metal wouldn't stand it for too long. So the airline ones go slower. It developed the engine intake system because a jet engine won't take in supersonic air. And I guess by far the most interesting feature of it is the droop nose, because when you look at Concorde, it's very aerodynamic, looks really good. Unfortunately, the pilots can't see the taxiway or the runway out the window in that form, so the nose droops and then you can see to take off. Coming into land is a different matter. Regular airliners come in at a fairly shallow head-up angle. Concorde comes in a bit like a swan, landing with its head held high, so the nose needs to go down even further, and that's one of the things that this aircraft worked on. When you go on board this aircraft, you'll find it's full of test equipment. It doesn't look like an in-service airline Concorde, and you'll see there are, I think, 8 seats on it because it carried its own engineers around the world with it when it was doing the test flying. John Dunleavy is one of those engineers who used to fly around the world with it, and that went on from early 70s right through to 75 when it finished the test program.
After 2 decades of working on Concorde, John Dunleavy is now a volunteer engineer for Heritage Concorde. Among other achievements, in 2014, they enabled the nose of Concorde 101 to droop again, making it the first Concorde to lower its nose since the retirement of the fleet in 2003. When we caught up with John, the team were in the middle of testing the nose droop's hydraulics, and we'll take a look at the nose in action later on. From the outside, there is little visible difference between 101 and the production models of Concorde, but this aircraft was fully equipped to test Concorde to its limits. So what was it like to be one of the test engineers?
Every test flight was an experience, and just travelling from, say, Filton to Moses Lake in Washington would not be straightforward. It'd be classified as a test flight, so we'd be cruising across the Atlantic Mach 2 and all of a sudden we'd be losing 20,000 feet with an engine failed, which was done deliberately, just to check the recovery procedure. And we used to say that those guys at the front are trying to kill us every time we get onto this aeroplane. Although there was a plan, it always went outside the plan on the flight. My name is John Dunlevy, and I've had 28 years on Concorde, the only airplane I've ever really worked on. I started my career on Concorde in September 1965, and I was so high. And eventually they trained us up to be engineers for the supersonic age. The testing program really would have been about 12 months, but with Concorde, there was so much technical information coming back from the sensors. All this orange cable leads to a sensor somewhere on the airplane, height, temperature, vibration, stress and strain, and all this feedback is analysed, and they thought, we've got a lot of problems here we need to sort out. So the original 12 months went on for 7 years. And this is the most interesting piece of equipment on the airplane. This actually holds the air intake control units, these two racks. And that is the first digital computer fitted to a civilian airliner. But your mobile phone would have more memory and capability of controlling things than these.
One of the most critical aspects tested by Concorde 101 was its ability to de-ice. Ice can change the shape of the wing and tail, which can increase weight and drag and even prevent the aircraft from generating lift. Improper de-icing can be fatal. So how would Concorde deal with this issue?
These TVs are for monitoring the icing conditions on the outside of the airplane. So on the outside of the aircraft we had 3 cameras, and the idea was to see how the ice would stick to the wing, because ice is a bit dodgy. So on a particular test flight in Moses Lake, we were following aeroplanes going into Seattle Airport, and they were reporting heavy icing conditions. So we say, okay, we'll follow with the Concorde. Nothing at all. Well, the airplane's so slippery it's not really sticking, which is good. Anyway, we've decided to throttle back and increase the angle of attack and go into an ice-bearing cloud, and it was, wow, look at this. And these monitors showed the buildup of ice underneath the wing and on this bottom lip of the engines. They switched on the de-icing system, and of course the ice breaks away and goes shearing into the engine and flying off the wing. And in the process, all 4 engines were slightly damaged, to say the least. So that was scary. But that just shows you the dangers of icing on aeroplanes.
The testing crew flew some of Concorde's most dangerous flights, trialling new conditions for the aircraft to see how she would react. So what if something went wrong?
Most importantly, but never used, the escape chute. And in fact, it can be used at Mach 2, which sounds unbelievable. So how do you save a person who's jumping out of an airplane at Mach 2 when his legs are going to be the first to exit? When the red beacon is lit there, it's time to abandon ship, and the crew will probably say, let's go. So the process of this, thankfully it's never been used in anger, this hatch explodes back, the outer hatch explodes out, and this chute or blade slides down. And the idea of this shield is to stop your legs getting whipped away from you as you exit the outer hatch and getting dragged towards the engine. So you can actually escape from this airplane at Mach 2.
Concorde's flight deck was operated by 3 crew members: the pilot, the first officer, and the flight engineer. Concorde's streamlined nose resulted in a narrow cockpit. It was particularly small for a passenger airliner, as well as incredibly complex. The space is packed with instruments, and panels cover most of the walls and roof. But John was able to make some sense of it for us.
Okay, so here is the master warning system. So anything red is probably a no-go for takeoff. So we obviously have important things like flying controls, engine throttles, electrics, doors aren't closed, stability of the airplane is wrong, inertial navigation system telling it's not loaded properly. We ignored those. 4 engine throttles, 4 power, idle power, reverse thrust, and the reheat switches, which as you go towards Mach 2, you would actually select the inboards first, followed by the outboards, so you get a smooth transition and you don't get this jolting effect. The later instrument fitted, or the last one fitted, was the traffic collision avoidance system. But virtually the layout of this is exactly the same as you would see on a production Concorde. On the prototype, the visibility forward was terrible. It was just a small window, both sides there, and almost like looking through a distorted periscope. And eventually, Pilkington Glass Company came up with this glass, and it's heat resistant, impact resistant, even at Mach 2. If you encountered a high-flying bird, which is possible apparently in winter, that glass is so tough it could withstand that impact. It's also heated with a very thin gold film. So the technology of the glass was fantastic, and the problem of lack of visibility disappeared on this aeroplane. Obviously the forward visibility during the landing phase is important. So on the landing phase, visor goes down, droop nose to 5 degrees. Are you ready? Right, first thing, hydraulic pump on. Right, first selection is to bring the visor down. That increases the visibility for landing. Now we can droop the nose to 5 degrees, which is the middle position. And on this one we can go all the way down to 17.5, which is the furthest the Concorde droop nose will go. It's kind of ridiculous because you can't actually see any reference point in front of you at 17.5 degrees. So on production aeroplanes it was reduced to 12.5 degrees. So we're indicating fully down and locked. Now reverse the process. We're coming back up. That's 12 degrees. Now we go to 5. 0. All the way up. It's working after 40 plus years on the original seals. I worked on Concorde for 28 years and I'm still coming back to enjoy it. So we're now, 30 plus years probably, and I'm still working on it. I still can't escape. I haven't found the escape door or the escape hatch.
The test programme finished in 1975, and in 1976, Concorde's first scheduled supersonic passenger service took off. British Airways initially flew from London to Bahrain and Air France from Paris to Rio de Janeiro, both adding flights to Washington DC and New York soon after. Concorde was the height of luxury and excitement in air travel, and Peter Archer was lucky enough to fly on Concorde as a passenger.
What was really noticeable difference about it from other airliners is when you're sitting on the runway and it starts, they put the engines to full power no matter what the loading. Full power and the afterburners, and you get pushed in the back. It takes off faster than other airliners, considerably faster, and climbs more steeply. The afterburners, they shut them off after about a minute, and then you feel like you're falling backwards when you're a passenger. Off you go, and when it gets out over the Bristol Channel or thereabouts and they go supersonic again, they turn the afterburners or the reheat on, and then you feel too thumped in the back as they come on, as it accelerates very aggressively to climb up to 60,000 feet. Once it's flying along, it's very steady. You're higher than other airliners. You're about 60,000 feet, and the others are 35,000 feet. So you can see them below you, appearing to go backwards because you're going at least twice as fast as them. So it does look very different from flying on in those days, a 747 or whatever.
But the allure and triumph of Concorde were not enough to keep the dream alive. The project had in fact faced great obstacles before the commercial flights even began. Concern over environmental issues presented by a supersonic aircraft such as sonic boom, takeoff noise and pollution had produced a shift in public opinion. Interest from airliners reduced, and in the end only Air France and British Airways took up their orders. Service was also limited right from the start of its commercial flying due to these concerns. Then, in 2000, an Air France Concorde's engine failed, killing all 109 people on board and 4 people on the ground. It was another blow for Concorde, and just 3 years later, the aircraft was retired. But the appeal and romanticism of the world's first successful supersonic airliner has never disappeared. Nearly all Concordes built are now on public display around the world. The pre-production aircraft 101 never flew commercially. After the end of the test program in 1975, it was decided that the aircraft should be donated to Duxford.
It, for a while, was at, I think it was Fairford or Bristol it's based, and then the government decided to donate it to Duxford, and it came here in 1975, just a few weeks in time, because a few weeks later the M11 motorway took away about a third or a quarter of the runway, and it wouldn't have been long enough for it to land. So it came here, then used its parachute to brake on the still relatively short runway, and then taxied round for the crew to dismount, at which stage they found they hadn't got steps tall enough to reach it. So there are some nice pictures around of a platform with a stepladder on top of it and the crew sort of dangling down from the door to descend for the presentation.